Today's lesson is our first lesson on notes for circles. So we're going to start with some vocabulary of circles. The center of the circle is the point that is equal distances from all points on the circle. So the center of the circle is named using a capital letter. So if you wanted to name this circle, we would name it circle, and we actually make a little circle with a dot, and then we use a capital letter next to it. The radius of a circle is the segment that starts at the center and is drawn to any point on the circle. So the radius comes from the center to any point on the circle. I'm going to go ahead and name that point B. And so a radius is a segment. So we'll go back to how we name segments using capital letters with a bar over the top. A chord. A chord is also a segment in a circle. A chord is a segment that connects any 2 points through the circle. So here is an example of a chord in a circle. And I'll name that chord with the end point D and E. And again, it's a segment, so we will name it segment DE. The diameter of a circle is the longest segment in the circle, and it goes through the center, connecting 2 points on the circle. So I'm going to go ahead and draw another segment on the circle. This time I'm drawing my segment from D through A over to the other side of the circle, and I'm going to label that point F. So segment DF is the diameter of the circle. The diameter of a circle is also a chord of a circle. It's also a chord. It happens to be the longest chord of the circle. The diameter also has the following property. The diameter is twice the length of the radius. Because if you look at our diameter here, we have a radius from A to D. We have a radius from A to F. 2 of those radius, or plural, we call them radii, 2 of them equal the whole diameter, df. The circumference of a circle. The circumference of a circle is the distance around the circle. When we're working with polygons, we call that the perimeter. But because this isn't a polygon, it is a rounded figure, we call it the circumference. And the formula to calculate the circumference of a circle is given by the following equation. Circumference equals 2 times the radius times pi. Some people also like to think of it as diameter times pi. And either equation will work because 2 times the radius is what the length of one diameter is. The area of the circle, which is the space inside the circle, is given by the formula area equals radius squared times pi. So radius squared times pi. So you will end up taking whatever the length of the radius is and squaring it, which means multiplying it by itself and then multiplying by pi. All right, so let's practice in this circle, identifying each part of the circle. The name of the circle is circle E. So back up here, how do we name a circle? We use the center point to name the circle. Okay, so we use the center point to name the circle. In our circle here, we're looking at segment AB, and we have to identify what type of segment that is in the circle. That happens to be a chord. The chord is the segment connecting any 2 points on the circle. So segment AB is a chord. Segment AC is a chord also, but it's a special chord. It's the chord that goes through the center. So that's chord AC, and that is a diameter. Segment EC. Segment EC begins at the center and goes to a point on the circle. Therefore, it is a radius. And again, if you have more than one radius, we call them radii. Segment ED, from the center to a point on the circle. It's also a radius. Segment EB. Segment EB is not on our circle. It's not a segment drawn on our circle. But if we were to draw in a segment from E to B, it would also be a radius. Point E is the center of the circle. Now, what are some calculations that we can do while working with circles? The first is working with the circumference of the circle. And we know that that formula, as we wrote above, is circumference equals 2 times the radius times pi. So as I look at my first example here, we're given that the radius of the circle is 4. We are asked to determine what the circumference of the circle would be. And we see 2 blanks here. We see an exact and an approximate. The exact answer will come from taking the value of the radius and substituting it into the equation and leaving pi in your answer. So that would look like this. Circumference equals 2 times radius times pi. We're going to multiply the 2 times the 4, and we're going to get 8 pi. And that is our exact answer. In fact, that is 8 pi centimeters. Our approximate example will come from typing that into our calculator. So you'll take your calculator and you will type in 2 times 4 times pi. The pi button on your calculator is found directly above the caret key, and you access it by hitting the second button. So that would be 2 times 4 times second, and then caret, and you'll see your pi button type up. There's the decimal approximation. Obviously, we know since pi is an irrational number, this is going to keep on going. And so I have asked you to round to the nearest tenth. And so that answer will be 25.1. So we'll go ahead and record that. 25.1 centimeters. Finding the area of the circle given the following information. So again, we're going to write the area formula for the circle. Area equals radius squared times pi. And now we're going to just insert our values into the equation. So area equals radius, that was going to be 11 squared times pi. Now again, exact means that we leave pi in our answer. 11 squared is 121, so this is 121 pi centimeters squared. And approximately, rounded to the nearest tenths, we'll go back to our calculator and we will do 11 squared. So you're going to hit the squared button, and then you're going to do second caret, and that's going to get you your pi, and then you're going to type it in, enter, and rounding to the nearest tenth is going to give us 380.1 centimeters squared. Those are the working forward problems where I give you the radius and you use the radius to calculate the circumference or the area. The next set of problems are the working backwards problems. What if I give you the circumference and I'm asking you to find the radius or the diameter? We still use the same formula. We know that the circumference equals 2 times the radius times pi. Now I'm giving you that the circumference is 36. So in place of the 36, in place of the C, I will write 36 equals 2 times the radius times pi. And now I am solving for R. Now in this case, we will divide both sides by 2 pi. In doing so, we will be left with R. So we're going to go to our calculator, and we're going to take 36, and we're going to divide by 2 pi. Now, in order to divide by 2 pi, I'm actually going to put 2 pi in parentheses. So 2 pi. I'm going to hit enter, and I'm going to round to the nearest hundredth because I'm following my directions and it says round to the nearest hundredth. So 5.73 is my radius. So my radius is 5.73. My diameter will be calculated by taking my radius and multiplying it by 2. So 5.73 times 2 is 11.46. Now I would like for you to try these 2 problems on your own, and then at the start of the next video I will show you the answers and we will complete the other side of the note sheet. Follow the way I did this one to determine the radius and the diameter for number 5 and number 6.